Hello everybody, Monica Tutor here, and today we're going to be going over some limits. So, limits are kind of a simpler topic. This is going to be a more introduction into limits, and this is going to be broken apart into two videos. In this video, we're going to be finding limits graphically, using, a graph. And the next video will be finding limits algebraically, so just without the graph, just simple math. But it's kind of good to get you started with the graph so you can kind of see what's going on and uh, kind of how this all works and the science, I guess the math behind it. So we're gonna first start with, let's take this point right here. Let's take this one. So let's say we wanted to find the limit as this is approaching, as x is approaching -4. So we want to see what do we get close to. So limit as x approaches -4. And that is your notation. In this case, it's going to be around 3. That looks to be in the half. Let's say 3. What essentially it is, it's kind of saying, it's like a fancy way of saying, oh, what point does this correspond to? So the limit as x is approaching -6 would be right here, whatever this is. The limit as x is approaching -2 would be whatever this is. The limit as x approaches 2 would be this. So that's kind of how limits work. And when they get complicated is when you have some piecewise functions with parts that don't go to each other, kind of, essentially. And I'll explain what that is right now with this example. So let's talk about this point. Looks like to be it's -1. So let's talk about the limit as x is approaching -1. So, we need to look at this and see, oh, where does the graph take us to? So, just like when we were finding the limit as x is approaching -4, we saw on both sides that it's leading to 3, okay? So let's look on both sides of this graph and see what it leads us to. Well, if we go from the left, we see that the limit as x is approaching -1 from the left this way, is actually going to be 0. So that's what this notation is. That's saying it's coming from the left, because that's the negative side. But now let's look from the positive side, from the right side. So as x is approaching -1 from the positive side this way, we see that it becomes what this is, because we're following this line right here. So it's whatever this is, and that's, we're going to say 5. So now we have two different limits. We have the same x coordinate, but two different limits now. So from the left we're going to 0, from the right we're going to 5. And in this case, when you talk about the limit, so the limit as x is approaching -1 just entirely, this is literally going to be, it does not exist, because for a limit to exist, both sides of the graph have to be converging on that same point. So just like, let's say we're going to limit x is approaching 6. If we approach from the right, we get to, we're going to say 3. If we approach from the left, we also get to 3. That's why, that's the definition of a limit, basically. So that's why the limit as we approach -1 doesn't exist. That's why that works, basically. So with this principle in mind, let me ask you guys this. Let me ask you guys, try these. So the limit as x approaching, let's say 4. What is it? The limit as, actually, hold on, 4 from the left. The limit as x approaches 4 from the right. And the limit as x approaches 4 equals what? So give us a quick try. Pause the video and then come back. And then I'll explain it. Okay, so hopefully you had a chance to try it out. And let's go over this. So let's see. As x is approaching 4 from the left, we need to see this is 4. And from the left will be with this kind of branch. So we're going to follow this, we're going to follow this, we're going to follow this, and we get to 2. Now, for the limit of as 4 approaching it from the right, we're going to follow this branch because this is coming from the right, from the right, from the right, from the right. Still going, still going, still going, still going, still going. And we get to here, which I'm going to assume is negative 5. So, if we have one branch of the limit going to 2, one branch going to negative 5, that means this limit cannot exist, essentially. That is what's going on there. Because this limit literally physically cannot exist because the branches are going to different sides. So, yeah. Limits are usually typically going to be when you're looking at them graphically, they will be the trickiest on piecewise functions, but you'll see that's actually pretty simple once you get the hang of it. So, yeah, that's kind of what I have for you when it comes to piecewises. So now let's look at a different kind of line. I'll just draw one right here. So let me draw a straight line at the very least. Okay. So we have this, right? And let's say we just have this line, okay? No matter what the equation is, let's just call this f of x, okay? So, I'll label my increments though. I'll do 1, 2, 3, 4, 5, 6, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's consider the limit as x is approaching 1. So right here. Or let's say the limit approaches x versus 0, just for a nice number. So as x is approaching 0 right here, what is our limit? Let's look at it from the left. So from the left, it goes this way, this way, this way, this way, this way, this way. We stop here. From the right, we go this way, this way, this way, this way, this way, this way, and right here. So this is our limit. So our limit as x approaches 0, f of x, this is going to be equal to 2, basically. So using what I've taught you, I hope you are kind of understanding that for a limit to exist, the limit as x approaches whatever that is, let's say y from the right or from the left in this and that, has to equal the limit as x is approaching y positive. So that's kind of, well, yeah, it's 4f of x. And that's kind of the rule on how to figure out if a limit exists. And that's how to find it graphically. So going back to our example on the right here, I hope it's kind of apparent to you that if the graph is continuous with no like asymptotes or holes in the graph, essentially the limit as x approaches any point will just be the value of that point, basically. That's why, so that's, if we take an example, oh, what is the limit as x approaches negative 2? It's right here. Let's say that's 3, right? But what actually is the y value when x is negative 2? And that's also 3, essentially. Because the limit is basically you are approaching very, very close to it, but not actually at negative 2, okay? So we're getting very, very close to 2, negative 2. Maybe we're like negative 1.9999999. And we're going to be close enough to 3 that we can say we're at 3, basically. And that's the same thing. That's the same value as when f of negative 2 is also 3. So that is how you do limits graphically. I hope that it was kind of simple for you guys and kind of understandable. And tune in later for finding limits algebraically. All right. Thank you guys so much.